Okay, so this is a question I found on Reddit, and it's a question from Slay the PE, and I thought it'd be kind of fun to solve. So the question states, an R22 compressor emits saturated vapor at minus 40 degrees Fahrenheit. The discharge pressure and temperature are 200 psia and 240 degrees Fahrenheit respectively. Under these conditions, the isentropic efficiency of the compressor is most nearly what? So we're trying to find the isentropic efficiency of a compressor. We know that it uses R22 refrigerant. This is also commonly called Freon, and it's a refrigerant that was banned by the EPA, I think, like back in 2010 or something, due to its high GWP or global warming potential. But to solve this, we're going to need to bring in the pH diagram. If we go to our PE handbook and go to our refrigeration section and go down to thermophysical properties of refrigerants, yeah. So we're going to grab this guy. Bring it in here. Shrink that down. Flatten that. Okay. So first, let me just draw a little diagram of what we're looking at here. So we have our refrigeration cycle. So we have our evaporator, condenser, expansion valve, and then compressor. So we are only worried about this guy. So we need we are given this inlet condition, and we're also given this outlet condition. So it says here, it's a saturated vapor coming in at minus 40 degrees Fahrenheit. So this guy is a saturated vapor. So what that means we know that the inlet is going to fall along this line somewhere, saturated vapor line. And we also know that it's at minus 40 degrees Fahrenheit. So we find our minus 40 degrees Fahrenheit line here. And then we can draw a straight line. No. Okay, that did not work. There we go. So I'm going to draw a vertical line here, and this will let us know what our entropy is. So around 101 inlet entropy. And then we're also given the outlet conditions. So that's this, 200 psia and 240 degrees Fahrenheit. So 200 psia. So that's going to be along this line. And then we also know it's 240 degrees Fahrenheit. So you can see these are constant temperature lines. So if we go to 240 and follow that all the way up to that 200 psia, this will give us our outlet condition. So I'm going to grab this vertical line here, move it there. So we know that our outlet entropy is around 141. But we also need to find our kind of idealized entropy or enthalpy. And we can use that by following this constant or this entropy line here. So all these guys are different entropy lines that we can follow. So if we come to the inlet of our compressor, follow that guy up, say it's here, it's going to be our next enthalpy line. Okay. So what we're really comparing here is this change in enthalpy against this change in enthalpy. So the bigger one is the actual enthalpy change across our compressor, and the smaller one is the idealized. So we're really just setting up a ratio of the idealized over the actual. So if I have our efficiency, this equals, let's call this H1, H2, H3. So really it's H2 minus H1. Oops, erase that. H2 minus H1 over the bigger one, H3 minus H1. So the ratio of this idealized over the actual. So to put numbers, so I'm going to say this guy equals 101, this guy equals 129, and H3 equals 141. So I'm going to plug these numbers over here. So 129 minus 101 over 141 minus 101. So if I get my calculator and plug that in, 21 minus 101 divided by 141 minus 101. So the answer is 0.7. And this is the efficiency of our compressor.